So in the last few minutes of the lecture, I want to introduce some of the network attacks in the early days. At least you are aware of this attack. So first of all, it's called this ARP spoofing. This attack is when we use ARP for communicating within a local area network. And as mentioned, this process, the device will send this frame asking, okay, what is the MAC address of certain IP address in the network? And normally the router will, when it receives this request, it will send back or announce to the network. This is the process of their original design. But the problem is that if there's an attacker sit in the local area network and it loads the gateway router, so IP address and MAC address, and it constantly send out this broadcasting frames to the network. Mention, okay, the MAC address of the router, of course, that's the specific MAC address, which is actually the router's address. So the MAC address for the router's IP address is here. It's like this malicious user. By the way, can you see the slides? Okay, yeah, so I will continue. Save time. Thanks. So this here, this switch, this malicious user, it wants to pretend to be this gateway router. So it sends out a broadcasting message to the local area network. Mention, okay, the MAC address of this IP address for the router is here, something like this. And it's just broadcasting. Then when this device received this information, and it thought this information, this frame was originally from this router, so it will just add to the switch forwarding table. Then what will happen that after this, then all the information sent from this device will check the forward table in its switch in the layer 2. And then, okay, that's the MAC address for the router's IP address, which in fact, the traffic will go to the malicious user. And the malicious user can see all the traffic. It can either drop this traffic from the LAN user, or it can simply relay this traffic to the real gateway router. That in this process, this ARP spoofing can have this denial of service attack. And also it can conduct this man-in-the-middle attack to capture all the information, either to relay or to drop it. Then it depends on the purpose of the malicious user. It can be relatively easy to conduct this ARP spoofing in home network, because then we have the whole control of the router. I will share with you the video of the ARP spoofing from last semester, when I give lecture at home. Besides this ARP spoofing, there's another spoofing called this DNS spoofing or DNS poisoning. If you remember the functionality of DNS, it is used to provide the mapping between the domain name and IP addresses. And this DNS, this database, some of the information are stored locally. So some of the information are stored in the router, some of the information are maintained by the DNS server. So if either of these devices got hacked and the information was changed, then the user will be either not able to visit the original, the expected web page, or it might be redirected to some phishing websites. And again, I will share the video with you and for you to see how it works. We don't have enough time, and we can only introduce the idea of it. Another type of attack regarding denial service is called ping flood attack. The idea is very simple. Ping itself is used to test the reachability of one destination, one IP address. If you consider there are many such requests to one single device, then the traffic will be increased, and at some point, then the traffic might be beyond the capacity of the recipient device. If the point is reached, then the device cannot respond to normal ping request or normal other request. That's the idea of this ping flood attack. In the ping, this command, you can directly use this ping option F. That's this flood, the shorthand for the flood, and then you can provide the target IP address. And you see, in this case, suppose I'm the attacker, I have much better bandwidth than the target, then I can flood the target very easily. But in general, it's not that easy, because for end users, for normal attackers, they don't have that enough bandwidth. And this is a simple ping flood attack, as I mentioned. And there are different types of countermeasures on it. And ping attack itself, ping itself uses ICMP packets. So when I demonstrate this IP tables for the firewall configuration, then we can easily block out some ICMP or especially suspicious ICMP packets. So it's doable by the ISP, it's doable by the local network administrator, just to block some ping request or ICMP request. In this case, if it's the attacker have this simple ping flood attack, so if it sends one ping request to the target, it will receive one ping response from the target. So somehow you see the attacker's the bandwidth usage is the same as the target's bandwidth usage. So it's not really a good news to the attacker. Then how can the attacker improve this type of attack? Then they have this source address spoofing attack. So here the attacker manipulates on the IP packet to change the source IP address as some others, not necessarily itself. Then in this case, the bandwidth usage from the attacker will be like half of the target's bandwidth usage. So that's good. It's like this. The attacker sent this IP, the ping request to the target. When the target receives it, here the attacker might randomly generate IP address and then add it to the source IP address of its IP packet. Then when the target receives it, it will respond to this IP address. Some of them are not reachable, some of them could be reachable, and it doesn't matter from the attacker's point of view. So in this case, the bandwidth usage from of the attacker will be half of the target bandwidth usage. There are many ways to spoof the IP address. Why can't the attacker just block or drop the responses? That's also, Christian, that's a good point. The attacker can't do this. It's quite easy, but we will see why the attacker, or like what's the motivation for the attacker to change other source IP address. Then we will see some other attack. For this type of attack, the ISP can also control it, because if in this network, the source IP address is supposed, like in the leading segments, it's the network's IP address. But if the source address is this one, it's a fake source address. Then the firewall or the ISP can easily drop this type of attack, this type of packets. Then this attack can be prevented. Then we see another type of attack called the reflective attack or reflector attack. In this case, you see for this ISP, it can check the source IP address. If it's not from its network, it's dropped. But if the attacker change the destination IP address as some IP address in the network, in the external network, but with the source IP address as the target IP address, then in this case, the attacker might be able to go through this firewall, and when these loads in the external network receive this ping request, it will respond to it, and then the target will receive the ping response from different loads in the network. If the ISP didn't have very strict rules, still sometimes the attack can be conducted. In this case here, yeah, it's here there's another, it's like called amplified attack. In this case, it's more interesting. Suppose the attacker loses some network IP addresses, and the attacker from previous one, you see, if the attacker sends out 5 ping requests, then the target will receive 5 ping requests. How can this attack can be amplified? Well, the attacker sends the ping request with the source IP address is a target, with the destination IP address is the IP address of a whole network. So it means if the network have many loads, many devices inside, each of these devices would respond to this ping request and send the response to the target. Then you see the bandwidth of the attacker is much smaller than the bandwidth usage of the target. Now, in some cases, the target bandwidth could be overwhelmed and could be exhausted by this amplification attack, by broadcasting. The last one is this user compromised host. That's different from this one. So then it uses dedicated roombs in other networks. Of course, this amplification attack can be implemented by these roombs as well. Then if all these roombs are targeting this IP address, then you can imagine if each of them use this amplification reflective attack or just the amplification attack, then the targets can be exhausted. The resource of the target can be exhausted rather easily. This is the general type of this attack. Is there some way to protect this attack? Well, maybe or maybe not. It really depends on the configuration of the ISP in the target's network, because like as defender, they can only configure the firewall here or like here, but they have no control of the attacker's power to conduct the attack. Do you have other? Yeah, that's pretty much the pin flood attack. Another type of denial is denial of service attack is targeting the design of a TCP protocol. I haven't mentioned this, but for TCP protocol, we mentioned this three-way handshake. So a client wants to talk to a server. A TCP client talks to the TCP server. Before the connection is established, they have this three-way handshake. So the client sends a request to the server. This is called TCP sync. Then the server will know, okay, after it receives it, this device wants to talk to me. Then it will reserve some resources for this for the future connection, and it will also send back the sync and the acknowledgement to the device. If everything works as expected, the client will send back an acknowledgement to the server. After these 3 steps, the connection can be established. But there's some vulnerability regarding security here. So the attacker can use a device to send SYN request to the server and never replies this acknowledgement to the server. Now, in this case, the server reserves some resources for the sync request, this sync message. It will wait for the ARC message from the client. It will wait and it wait, but still there's no ARC message from the client. At some point, it will drop. But between before it drops this, it ignores this sync message. So it already reserved the service, reserve the resources at the server end, and also it waits like some seconds for the ARC message from the client. If the server receives many type of this sync, it's called half-open sync message, then the resource of the server could be exhausted. That's the design of a TCP protocol. It's not easy to protect or prevent this type of attack. I think that's pretty much the DOS attack I want to mention to you. It's